Hi, today we look to the new topic in Java JDK 8th version. And first, I would like to introduce to the new technique as a functional style programming, or just Java util function library. And addition to Java 8, it's really a huge step forward. And basically, we learn how to use a Java Lambda expressions during this session. And how to create a project. First, we need to create new project in your any IDE, and you picking minimum 8th version because we need the Java 8th version functionality, and those additions as a Lambda and functional interfaces. And now it's long-term support at the moment's 11th version, and I recommend that you use it minimum 11th version at the moment. Later will be maybe 17th version and etc after each year. And first we need to create a Java 11th version project. And when we creating, we just picking some name like Lambda Expressions. And when you're creating a project, we need to know about the Lambda and how it looks like. I'm just opening here. Before, the Lambda expressions was really pain when you need to create some functionality, or because in Java there is no delegates, and when there is no delegates functions like in C# or something, and you need to pass some functionality through the function. For example, you have some program like some class. Pay money, for example. Some class pay money, and you would like to have, for example, different methods or different functionality when you're paying money, like pay money, and you, for example, have some interface. Like I pay, for example, I pay interface, like which have some methods like void um, pay, or pay, we enough the pay. For example, abstract method, which is we using the different method each time when we need to pass some pay methods here. And in pay money class, we would like to create some stuff like void pay method, for example, and we passing, for example, I pay some stuff.
Sorry, could you share the screen?
Oh, sorry. Okay. Yeah. Share the screen. Fine. Yeah. Basically, I'm just showing what was before the Java 7th version, and when we move into the Lambda expressions, we need to understand how that Lambda expression helps to solve some problems. And when you have some class like pay money, and you have that method like pay method, for example, and you passing some functionality, because in Java there is no delegates like other as a type, like in C# there's delegate stuff, etc. In Java there is no delegates, and instead delegates using the interfaces. For example, if you need to pass it as a parameter to the functional method, as a other method or function, you need to passing some, for example, type reference. Like for example, in our case, we passing the interface. And interface have only the single method like pay, and we need to implement different payment methods or different functionality for each instance of iPay. And when you're passing the iPay, for example, method, you just using here iPay dot, for example, pay. And we have implementation of our pay money class. And for example, here we creating a separate class for each different institution or organization, or who cares, just some different classes like bank or ATM. Maybe it's better. We have ATM, for example, and ATM implements that interface like iPay. Like how it's working in that ATM. Like we implementing basic functionality, like to show it's how it works. Like ATM payment process, for example. And here it's like saving, storing some information. I don't know, just void sending or save to DB, for example. We have to just simple implementation of, for example, for ATM class, like saving to DB, just some process here, and we calling like saving to DB, for example. We have the payment method, which is unique for ATM, for example. And we also have another class, payment in online payment, maybe. Online payment. We have different classes which is using same interface, for example. And IP. IP. Oh, implement. Sorry, I forget implement. IP. We implementing here online payment in progress. And basically we have two classes, online payment and ATM payment. And we have the pay money like class, the parent class, and we have the main for testing purpose. And now when you creating some instance, for example, pay money, here it's our function like pay money dot pay method. And yeah, and when we need when we have some like class which is controls the payment main functionality, how it work the payment, but the background process for each pay method is different. In different classes there is different implementations. We just using like for online payment, we creating online payment method. Sorry, online payment, and other is ATM, new ATM. We have two different payments, payment implementations or pay method implementations, and when we need to pay the method, we just passing that object. We just passing online payment, and when you're running, you getting online payment function executes like online payment in progress, and you're able to make it more like payment successful, etc., to print it out here. And when you progressing ATM, you're progressing your ATM payment method, like ATM payment process saving to DB, for example. Basically, we have the parent class, which is controls your pay basic payment functionality, and different iPay interface users or classes runs different process for payment. For example, online payment have own rules, and ATM their rules. Yeah, and when you're creating, you should create for each instance, you should create different interface, different class. Sorry. Um, why is not so great? Because when you need to make some simple calculations, for example, and you passing some stuff, you need to create separate class for each instance. For example, you would like to make math calculations. We creating, for example, interface iMath, void calculate. Sorry, iMath should be interface and public by default, but we just leave it. It's not a big problem here. Public interface iMath have single calculate function. And now if you have some class like math, which is implements iMath. Oh, we don't need, sorry, implementing in different. We have some just execute or void calculate. Okay, we just leave it calculate. We have the math class, which is calculate something like any expression, for example. And if we need to calculate any expression, we passing iMath interface, and we calling iMath.calculate. Basically, we use the same name, but it really doesn't matter because we passing some functionality here, and we executing that functionality inside the math. And now, if I need to multiply, we just creating multiply class. And we should implement our multiplication of iMath interface. Because we use the centralized calculate method, we should implement calculation here. We just, for example, multiply test. Of course, we're able to create some parameters, etc., but I'm just showing without any parameters here. And we just multiplying, for example, 10 multiplied by 10. We have some calculation like multiply test here. If we need divide, we should create divide class. Implement iMath. We just print it out, divide or division test. 10 divided by 10, for example. Why it's yellow? Replace with 1. No, we need that. Okay, we just have some calculation like divide, multiply, and etc. And now when we creating our main class, math, or math processor, or doesn't matter, we just would like to calculate some IMath. We're able to just call it new and multiply, or just create instance and then pass here math dot calculate new division divide. You're passing some functionality like multiplication and division. And you see multiply test 100, division test is 1. You're able just implement separate class for each, and if you have a lot of different expressions, basically you creating for each different function or functionality different class. Why it's not so fancy and why it's Lambda introduced for those single method interfaces used as Lambda expressions. It saves a lot of boilerplate. You don't need to implement separate classes. You're able to pass only that functions, only the expressions. Sorry. How to fix it and create it using the Lambda expression, our multiply, divide, and math like process. Make it much easier. Like instead of passing new multiply, we're able to pass some lambda expression. And what is a lambda expression? Basically, anonymous inner function, nameless function without boilerplate code. That means we're able to pass some functionality without any function naming. We're just passing some parameters and some function body. Satisfying a functional interface, you need have interface with one abstract method. Basically, here we have one abstract method, pay. In Java, like we go maybe to math, we're able to mark functional interface here. And is it okay? You have single method functional interface. That means here is you're able to use as lambda expression. If you're creating another function which is not second is a functional interface, you see the problem. Multiple non-overriding abstract methods found in interface. You can't use two abstract methods. In Java 8 and 9 version, you're able to use it also default, void, and those type methods like static, int, sum, or you're able to use static, return one. Static default method, and Java 9 you're able to call create print private method also. Because in Java 9 added private method, in Java 8 added default and static methods inside interfaces. You're able to use it those also. If it functional interface, you need to have only the single abstract, like abstract function. Here is by default abstract when you doesn't have anybody, nobody here for your implementation. That means here it's abstract method, and you need to have only a single method for abstract. And if you follow that rule, you're able to use as a lambda expression. Writing the lambda, it also recommends to write a single line lambdas. Doesn't use the multi-line. You're able to use as a block of multi-line, but Lambda goal is to use a single line expressions. It's easier to read it and it is worth to use it. Writing the lambda, you're able to make it easier implementation. And yeah, there is two different types of lambda expressions usage. You're able to use the lambda with parameter and output here, or just use it the method reference also. And here we also see more and more examples with lambda expressions. And maybe I will show you now how it works. When you have a math interface, basically all backward code which have a single interface method, you're able to use it as a lambda expression. Single abstract method you're able to use as a lambda expression. Basically all the graphic libraries have the, for example, events or something with single method you're able to use as a lambda expression or as an anonymous function. How to use it? Instead of implement multiply, divide, there is another, for example, sum. Yeah, we need to implement sum. We just easily able to pass to calculate new sum, not class, but lambda expression. Because our lambda doesn't have any parameters, for that reason you use lambda empty parameters, making empty brackets. Arrow says here is a lambda expression. If you have some parameters in your function, you use some name, doesn't matter which name you're picking. Variable on the right side to implement the lambda expression. Because we have the void function, we know that we have void function here. Void calculate, no parameters, it not returns anything, we just need to execute some function here. And we able to make it like system out 10 plus 10. And we say here like sum of how we written here. Sorry, I pay math multiply. Oh, multiple test. Okay, we just adding sum test, and we just adding that sum to our result. Sorry. Okay. Yeah. And now, as you see, instead of creating new class, implementing interface, and implementing that function pay math, for example, for some class calculate, we're just able to pass straightforward our expression inside that function if you have the parameter as the interface with the single method. And when we're running our program, you see that result will be some test, it's 20, it's work. You're able to make any functionality passing here, you're able to call any method here and etc. And here it's really easy way to use it as a functional style programming when using the lambda expression. Basically, there is the also implemented I don't know, is it possible to find it here, some basic interfaces for each goal. What is that? Okay, I need to open the image like Java util and function, sorry. Here you will find the whole whole functions for your Java util function library, which has added some interfaces like supplier, function, b function, predicate, consumer. Basically, here are the functions which have single parameter and returns, for example, integer, no, or some type. There is some without parameters returns something. There is two parameters return something, and etc. Predicate basically takes the logical condition and it checks, like have some method like yellow, it's test. Predicate have test. Consumer have accept abstract method. Runnable have run, and some supplier has get. And basically there is a lot of those interfaces added to that functionality, and you're able to use it instead of Lambda creating your own interfaces here. If I need to check some condition, for example, I'm creating interface, for example, condition checker, or who cares, like condition checker, for example. And we should create boolean, for example, check. Boolean check, and we should add boolean condition. Yes, or we just passing some condition and it checks, it returns true or false, as we see here. Of course, here maybe we need some type. When you have the predicate class, I will show you how it looks like predicate first. Predicate class or interface has only boolean test and pass some parameter like t. As a generic type, I don't know, just there is some also we discussed already about the generic type, and when you're passing the t, you're able to pass any type here, and maybe we create condition checker the same as predicate. Here we're passing t because we need to pass any type of value, and when we passing that value, we checking is it returns true or false. Basically, we have the function which is returns true or false when you're passing some condition t, any variable, any variable able to pass to your condition checker interface. And when you're creating interface here instance condition checker like string condition checker, and how to implement using the Lambda expression. You're able to write like condition checker equals, and you're able to write the Lambda expression straightforward here. We know we have some parameter. Instead of empty parentless, we adding some letter. Doesn't matter, X for example. X and arrow means like we taking the single parameter as the string, because we let make it here string or any type here, and we able to passing and checking x dot length, for example, less than 2. We just making some condition like which is checking is it x less than 2, then we return true, else we return false. And we should also call it our check function, which is passing our string, for example, hello. And this function should return true or false. We're able to just make it result equals condition checker check hello. And we printing out the result. is longer. Is, for example, word length is 2, for example. We checking is it word length is 2. We running and we getting result. Is word length is 2 or less than 2? Sorry, length is less than 2. We returning false. If you reduce the code to the single letter here, you will get some result is true. And basically there is no reason to create your own methods or interfaces like here, like generic condition checker. Instead of this, you should use from the library Java util function, because you need to, for some programmers also, you need to know what do you mean and which type of interface you're implementing. But if you need it, you're able to create your own interfaces here. But if you need to check condition, instead of this, basically you're able to create predicate. And predicate have not check or test method. And when you're using the predicate, you get the same result, true. Because our predicate function has boolean test t. Basically the same function is here, but here you will get from library and you don't need to create separate interfaces. And basically all stuff already implemented for all reason when using those Lambda expressions. And here, when you have calculation, for example, I will show you why Lambda is great, because you're able to create those different calculations. Like you have some IMAP list, like IMAP list, for example. IMAP list equals new area list. We just creating and we add, oh sorry, IMAP list, add some stuff. Basically, you're able to add some functions to math list. Sum, divide, multiply, other, division, sum, multiply, and some expression. Of course, you're able to separate that functionality, but you have the array list, you're adding some functions, and you're able to just call it for loop, for, sorry, IMAP, item, IMAP list, and you just calling item. Basically, you're calling your math class and executes calculate method, which is executes the Lambda expression here. And instead of calling this math twice and creating two separate classes, we just running and see the results. And basically we adding that different functionality and get some divide, multiply, and other expression results. You don't need to create separate class for each instance and passing here. You're just adding some functionality to array list and just execute this using calculate function and passing this functionality. Basically, there the Lambda expression is to pass some to method pass another function or method, like as a parameter, instead of simple parameters like variables or references. You passing some method also. That's it. And here you have a lot of, as I mentioned, predicate, supplier. Like be able to make supplier. Just look to those different interface. Consumer. There is some B consumer with 2 parameters, B supplier with 2 parameters, function, B function, 1 and 2 parameters, also consumer and function. Function basically takes 2 parameters, like first parameter, which is which type of value you passing and which result you returning as a result, like return type and string calls function. If you look inside that function, you will find interface takes 2 parameters r and t. Basically, you return any and you be passing t. You passing some t type and you getting some r type result. Consumer, you have that void function with 1 parameter. Sorry, and consumer, supplier, you just returning. If you supplier, you just returning some result. How it looks like in usage when using the Lambda expressions, because you're able to add those stuff as parameters to your own implementation. When you're creating the function, you're able to pass those stuff. We use supplier. Supplier basically has supplier is getter. Getter, which is returning string, because we passing the string. If you return different type, you return different type. We should return something. And if you're writing the single expression, you don't need to write a return keyword. And you taking empty parameter, because we doesn't have any parameters, and we returning something. You're able to write a return if you're using multiple blocks like this. Return string like this, but if you're writing instead of this only return, you're able to return string. Basically, here you need to call another function or something and return the result as a string. Supplier gives like this only. Like, you're able to use it like string hello and call it function like substring or uppercase. Yeah, to uppercase, for example. And we just writing like this. And we need to print this result to console using supplier dot get. Because supplier has the getter, it returns some result. As you see here, we got hello in uppercase. Hello. To lowercase maybe exists. To lowercase, we should get to lowercase hello. Yeah, hello, it's lowercase. Basically, you're writing here functionality, calling another function if you need it, and just returning as supplier get result. That's it for this supplier. Function. you're able to get string and return as a string or integer, or doesn't matter which type of here you're passing as a result. And you need to create some variable like x, or doesn't matter which parameter, because you have a single parameter, and on the right side you need to return some result using string x dot result, for example, size, length. Yeah, if you're returning integer, you should change here integer, for example. And now it works fine because we picking string, x is string type, and we getting length, and after this we returning length. And if you need to print it out that function, sorry, we're just printing out system out function dot apply. And when you're applying, we need to pass it here like hello world, for example. And when you're passing that, you will get the length of this function, like length of function. And we are returning here. Length of function is 11 words, 11 characters. And here also you see the yellow color, you're able to change it to method reference. Instead of using the lambda expression, because here you see as a repetition of x lambda x dot length. Instead of this, you're able to call string length. Why it's working? Because you passing some parameter, it knows you passing some parameter is a string, and dot length basically it's reference to string length function, and it's method reference. We're able to use both way. Lambda expressions, I recommended to use it when you're learning, and after you're learning, you're able to use the method references also, because you know that function takes a string. That means that string or any you picking string and you're calling length function. That's it. You're calling length, and you know that string length function returns integer. Or your custom function, doesn't matter if you have the person, for example, string name, int age, and you just creating some getter setter, for example. Oh, sorry, what's going on here? Scanning indexes. Yeah, we generating getter and setter, for example. Get and set name, get set name, get set name age. You know that your function returns a string and this one is integer. And if you have that function, different function using person function, you passing person and you returning integer, for example, age. Doesn't just have function here, age. And in age function, you will apply person. You know that here is a person, and you're able to use method reference double, like in C++ language, and you're able to get or set age. Because you need to return integer, you're able to use only get age because you're passing person, but you're getting as integer. And oh, sorry, I'm just failed here. We need write age equals first functionality person dot get age, and yeah, as you see here, you're able to get age, and now age call dot apply. We should pass some person, some object. We passing object, and by this creation of object, we getting the age for the person. Yeah, I'm a bit failed here. But if the instead of method reference, you're also able to use the Lambda expression, or instead of writing in separate lines, you're able to write the same like here, person get age as a method reference, or you're able to use it as a lambda, like picking person, like person, and writing person dot get age. Basically, when you're writing a lot of lambdas, you will see that in some cases, better not to repeat like person, arrow, person dot get age. Instead of this, just writing person get age if you need just to return some function from that class. For that reason, they introduced person.getAge, because in stream library later we will see when we discuss about streams that you need to pass some parameters, the lambda parameters, and you have chain and constructs, and it's easier to passing as a method reference. But yeah, when using the lambda expressions, it's really easy to use it. And it's better than implementing a lot of functions and creating, of course, separate classes and interfaces. Instead of this, you need to remember, if you need some condition, you use predicate. If you need some getter, which is return something, you use supplier. If you need that some parameter with some function which is take parameter and returns some result using function. And if you need consumer, basically we need to check it how it works. Consumer equals, we need to look to the method void accept, basically void method with single parameter like a setter. Empty, not empty, is have single parameter param, and you just executing something. System out, for example, param dot length multiply by 2, for example. You're just taking this function parameter consumer, like the taking some string or person, it doesn't matter, and working with that object reference and calculating. After calculating, you're just printing. And here how it's consumer working. Has input and just execute the code. And of course, you're able to create the classes like Lambda Functions. And for Lambda Functions, you're creating, for example, void. You're able to create any function which is taking some parameters, like void consumer, like you're able to create t if you need it, or just real consumer using only the string. And you're also able to use predicate inside two of those predicate and just custom function. Using predicate also takes the string, and here it's entering like also some variable, for example string str. Just we creating some function using Lambda Functions class. Inside of this we passing consumer, predicate, and string, 3 parameters. And here able to create your functionality. If consumer or supplier, just supplier maybe, supplier, and if supplier equals, what we need to check it here. Okay, if supplier get equals hello. For example, we have some if supplier get equals hello. For example, we passing some functionality from outside, like as a supplier, and we just, if hello, we just executing predicate, for example. Predicate dot test string. And in predicate we passing some functionality. If hello, we testing the string. For example, it's working like this. I'm just creating some function which is custom function, getting supplier. If it's hello, we just calling also predicate and testing that stuff. Of course, we're able maybe to create some return here as boolean, and return result, return false. Basically, if hello, we returning our check of predicate test. Predicate returns that logic passed from the outside. And as you see here, why it's really strong and good stuff here, because you're able to pass your predicate or your logic from outside. Instead of writing logic here, predicate test, I'm just executing this test, but implementing functionality outside that in any main or other function. Like when you're creating the Lambda Expression class, Lambda Functions, for example, new Lambda Functions, and we calling, for example, Lambda Functions custom function, we passing supplier. We're able to write a method reference, as you see here. Oh no, we're not able to write. Yeah, we doesn't have that. Is it possible to create some static? I just tried here. Public static string public static final string hi. Hello. I'm just testing here. I'm not sure now it's working or no, it's not working. Sorry. Okay, we need to create a getter, for example. Just a string get high, return high. We just returning a string get high function result. Get high. Oh, what? Custom functions. Well, we need static also. Let's check it here. String dot. No, not working. Why? Okay, we just passing the supplier in different way. You need to create a supplier, which is string at the moment, s, and our supplier returns something like void function, which is returns our s.get. Oh, what? Why it's not working now? Supplier, string supplier equals. Oh, yeah, I'm sorry, I'm just failed here. We don't need to. Are we passing some parameters or not passing some parameters? Okay, we need to check the supplier. Returns some stuff. Yeah, it's only returning something. And we able to return only using, that's why we can't use the method reference. We able to return some string like hello. It was my problem here. Or just able to use constant like Lambda Functions get high. Oh, yeah, you're able to use it if using the class. Lambda Functions had get high because we have the static method. And yeah, you're able to use it here also. Lambda Functions get high. Now it works. You're able to pass s or Lambda Functions get high, and here you need to pass predicate. And predicate, you're able to make it any predicate for any text. Like for any test, testing, for example. And here we need to pass predicate. Predicate, for example, string predicate equals, and our condition for string predicate. Like x dot start with test. If our predicate starts as test, we should print something, and here we're passing predicate. The basic idea here, you're able to create a custom function which is taking custom logical expressions, and as you see before, we created a lot of additions to the list and able to for loop like different functions to pass to here and get different results. Like and hello, where is that output for our case? We need to comment it here, and here we commented, and here we commenting also all that code here. Running again. We not getting any output because we not printing it. Here you get the output as true or false, I think, or not. Oh no, not sure now. We need to check it. Lambda functions. Yeah, we get boolean. If we get here boolean, you're able to create the result. Result equals, and we use our result to print the result of our predicate. System out result plus result. Sorry. Result here, and we will get some results. As you see here, result is true. And for example, you have the single predicate, but you're able to create that separate predicates. Those lambda expressions really powerful stuff. We're able to do anything and to make a lot of stuff, like here's a filter or just checking. Basically here able to passing some different strings. Maybe you have some array equals testing test no prob no pron drawn good tester and etc. You have some array, for example, and we just for string str for string str array, and you passing creating the loop, and instead of testing you passing your str, sorry, yeah, and yeah, you have some boolean result, lambda expression, custom function, get high, you getting high, or just it's really pointless at the moment. We just passing hello to use to work with predicate. If you not use hello keyword, you not activate this predicate. Basically, you're able to control that. You're able to have as many as you need parameters, as many different situations, you're able to create filters, etc. And here we're passing str from library, from array. And here you will see how many keywords matches in your case. True, true, false, 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 true. Basically, you're able to mark it which is true or which is not false. False and true and etc. Of course, when using a streams API, you're able to make it also easy way as array.stream, and a lot of stuff added to stream library, for example, find first or other stuff. But we're not looking now for the stream library, we look at now in the future. Basically here what you're able to do is those lambda, and you're able also create a method reference if you really don't need it, those arrows here. In some cases it's easier to write a method reference. And here basically you see the functionality, you're able to pass a supplier, predicate, and etc. Like you returning predicate, test, and so on. Yeah. And here is a whole library using functional style programming. And here I'm not sure what else you're able to do. Function, method reference, compare. For example, we have an old way to sort elements inside the list. For example, you have the old school implementation for comparable or comparator interfaces. When you need to sort some array list, you have the list of, for example, words list. New array list. And here you passing list of, for example, some static list. Like Tom, Peter, Anna, user, who cares, just some names, yeah. John, actor, okay, actor. We're just creating some list of names, some string list. And when you need to make it sorted, you need to use the function, for example, collections.sort. And you're able to pass here list and comparator. List here and new comparator. And when you doing like this, you should pass in comparator interface, which has one abstract method you need to implement as anonymous class. And when you're using like this, you should get O1 dot, for example, we need compare O1 dot compare to O2. And here is an old school implementation using JDK 1.7. From Java 8, you're able to make it the same functionality using the Lambda, because you know that you have the single compare method, which have two parameters and returns integer, like 0, -1, or 1, when it's equals, not equals, and etc. When it's equals, it's 0, when it's less, it's -1, when it's more, it's 1, like returning that, how it works, that compare function. And if you needed to make it same using Lambda expressions, you're able to pass list, and you're just able to make it two parameters like a, or just o first, o second, and just returning comparison like o1 dot compare to o2. And as you see here, you're able to replace list.sort. Because we're using collections, it's a main class. Instead of this, you're able to pass list. There is another option, list.sort, and here we're passing comparator, new, or just passing this comparator. Basically the same, working the same, but you sorting only that list you needed, not collection, not a basic case. When you have some function, when you need pass some list, any type of list, and sorting that list, you just use the real list. And for that case, you're able to also use that same in shorter way using method reference. We just alt enter with method reference. You're able to use it list, sort, string, compare to. That's it. It works the same way as like this code, this code, this code, or this code. But you have that only the single line, and it's really less keywords instead of a lot of boilerplate it was before the Java 8 version. And list sort also it recommended to compare comparator new natural order. There is list sort comparator natural order. There is different types, of course. Yeah. Be able to use that type of function call. It's, I think it's here natural order. We need to find natural order. Basically, it's helper function inside that interface. Instead of calling some comparing functions, automatically have implemented helper function. Be able to use basically this function or any other stuff. But yeah, how you able to compare here? And also in comparating interface or comparable, when you have this stuff, you able O1 then okay compare to no, it's not exists here. There is some comparator comparing. Oh yeah, you're able to make it more complex comparations filters, like you're able to make it comparator comparing, because comparator interface have some stuff added also with comparator comparing, able to pass the function as the Lambda expression. Comparator comparing, be able to pass in by what to compare. Because we have the string not a person, we're able to compare with string. No. Yeah, you're able to make it more complex comparison stuff here. Comparing, basically able compare like lambda O1, O2. And we just comparing like this. We comparing O1 dot compare to O2. It's too much, no? Oh, we need to pass some different, sorry. We passing is it working like this? String compare to. Oh, it's too much mess here, sorry. Yeah. Yeah, you're able to make it more complex stuff. I forget how it works here. But here, when you have some different approach, when you have some person, for example. If we adding some persons, it will be easier here, because I will show you maybe that example. Basically here you're sorting this list, comparing first get last name, you're sorting by last name, and then you're comparing by first name, and after this you just sort that list. Here is more complex sorting when you need it. Yeah, be able to make it those also from comparator. Yeah, comparing and comparing and etc. Yeah, there is some helper methods already implemented. But here's how Lambda expressions works, and how it helps for older interfaces. Like if you have the process or threads, you should use runnable, new runnable. And if you would like to implement runnable interface, you should implement functionality like this. You should use 5 lines. Instead of this, with Lambda expression, you have the single line. Also, for example, you have J button or any APIs, new J button, you're able to add action listener. Add action listener, new action listener. Oh, sorry. New on click. Add or new action listener. Yeah, and that action listener has only the single abstract method. Instead of this, they suggest to replace with Lambda expression and use single line button click functionality. Button clicked. Basically, if you need to create a UI, you're calling the single line instead of 5 or 6 lines using the Lambda expressions, and you're able to pass any type of functionality here using that interface, which is also from old school action listener libraries, like from old libraries, which is since 1.1 Java version. It was action performed library, which is have single parameter. All the interfaces which is have single abstract method, you're able to use as a Lambda expression. And basically here action performed, as you see, there is some which is now consumer, maybe consumer. We need to look to consumer. Consumer. Oh, okay, we delete this. Yeah, consumer has accept single parameter. And our action listener accept is void function and accept single parameter. Basically, here is a consumer interface. Yeah, event listener is a marker interface, as you see here. Basically, there is way to rewrite the whole Java JDK library to reduce a lot of useless classes, but at the moment I think that they never do this because there is libraries and already implemented. It's no point to rewrite. Here is an empty interface, just mark that event listener. If you need to mark like any class which is like event listener, for example. And yeah, for today it's over, and